Okay, hello everyone. We're doing, yes, exam revision papers. So we're doing grade what now? Grade 9. Paper 1, this is last year's paper. It's a provincial paper, Gauteng Department of Education. Yes. So I'm doing question papers now because of at least I can be able to cover a lot of topics at once. So if I'm doing the paper, I might take more time because I'm explaining. I'm not just doing the questions, so that at least you understand and you are more prepared for the exams. So let's get started with it. Oh, with this one, I think you write on it, so I don't need paper. I can just work it out here. Yes, I can work it out here. So question 1, they give us this, so let's read. I hope you can see the questions and then we just work it out here. Circle the letter next to the correct answer. What is the product of this? The product, what is the product means multiply. So if I multiply that and that, remember, I'm going to apply the only 3 rules of exponents according to me. When we're multiplying exponents, we add. When we multiply in powers of the same base, we add exponents. When we're dividing, we subtract, and then we have a power raised to a power, we multiply. So here we're going to have to add, and then we're going to have a 4, a negative and a positive becomes a negative. So 5, 2, which is 25. So the first question, A will be correct in this case. Because of we're going to subtract 2 from 4, so you're left with that one. Which of the following is equals to this? Use the distributive law to calculate your answer. Okay, the distributive law says what? Says if you multiply something like this, if we've got, let's say, 2 answers inside, I really hope you can see what I'm writing. When you multiply, each will be multiplied to this plus A will be multiplied to that. That's the distributive law. Each one inside the bracket will be multiplied with the A outside. So if I have 6, can I work on it down here? If I have 6 times 85, if I'm to expand 85, I'm going to have 80 plus 5, and then I'm going to multiply this. So each will have what? Each will be multiplied. In between it, it's a plus, and each will be multiplied with the 6. Yeah. So let's work it out. Let's work out first this. 6 times 85 is how much? 510. And then when we expand it like this, we should get the same answer. So 6 times 80 plus 6 times 5. You see we get 5110. Yeah. So the answer will be D. So don't choose this one. They were supposed to put it in brackets so that you know that you need to multiply inside. And then in between, there's a plus. The 85 is made by 80 plus 5. If we're expanding according to, what do they call it? Place value. So we're going to have something like that. And then here we can have a times. Can you see? Here they missed, it's almost similar to this one, but they're missing 0 here by the 8. So I hope you can see it. So 144 as a product of prime factors is what? You still remember how to do this one? Let me write here. This thing, I hope it's not disturbing you also. 144, you use the ladder method to calculate this. So you're gonna divide, divided by 2, I get 72. So you look for a number that goes inside without a remainder. All right? And divide 72 by 2, you get 36. Divide 36 by 2, you get 18. Divide 18 by 2, you get 9. Divide 9 by 3, you get 3. Divide 3 by 1, you get that one. So as a prime factor, I'm going to write this. The product of the prime factors will be 2. How many 2's do I have? 1, 2, 3, 4. So I have 4 2's and 1 2 and 3 and 2 3's. Then you just confirm it with the calculator there. see, that's your answer there. I hope you can see it. So four 2's and 3 2's. So which one will be correct? So C will be correct. I hope you can see it there. Can you see? So you know, with multiple choice questions, you don't really need to look for the answer. Work the answer somewhere else and then just go select the correct answer, because if you try to force it, you're gonna end up, you know, yeah, you're gonna end up forcing the answer. Okay, so they gave us which term is missing. They gave us this, so we're supposed to identify a pattern before we even look at the question. So from 3 to 6 they multiplied what? Can you see the numerators is the same, so we don't have to worry about the numerator. The pattern should be here. From 3 to 6, we can say they are adding. They added with 3, yes, but it's not consistent. So I can't say they're adding. But what if I say multiply? From 3 to 6, I multiply by 2, I get 6. 6 to 12, I multiply by 2, I get 12. So from the next one, I'm going to multiply this by 2. I'm going to get what here? 1 over 24. Can you all see? So that when I multiply by 12, I get 48. So they're basically multiplying. So B will be the answer there. Okay. Calculate the value of this if x is minus 5. So they gave us. Can you see the questions? Yeah, I hope you can. I'm going to write it here. They gave us this expression. They want to know how much is this when x is minus 5. So I'm going to substitute what? Minus 5 squared plus 4 minus 5 plus 3. This squared will be 25 positive. If you're not sure, use a calculator, because of a negative and a negative will give you a positive. 5 times 5 is 25, and 5 squared is what? Is 50. So here you're going to have a positive 50 minus this is 20. 4 multiplied by 5 is 20, and a positive and a negative gives you a negative. So this and this will give you how much? I think 30, and then you have 33. 33. Did you see all that? And then it means the answer is C. Can you see how to do it? So here we have properties, number, what do they call it? Properties. We revised prime factors. Can you see? We revised patterns. We revised algebraic expressions in one question. In just one question one, we were able to revise so many topics. Okay, let's go to question 2 quickly. Let's not waste time. Okay, read the question there. Blah 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 blah. Hope you got it, ne? So they're saying identify. So here, what you need to know, so you need to identify each of this as according to the number system. Alright, so you need to know what all of this mean. So can I just revise here at the bottom? What are natural numbers? Natural numbers are whole numbers. That's from what? From 1, 1, 2, 3, 4, 5. So they're not decimals, they're not what? They're just straightforward like that. And then what are whole numbers? Whole numbers are numbers starting from all the positive numbers starting from 0, and then they're just like that. So I'm starting inside out. Natural number. Okay. I think they're supposed to bring this one inside. Which one? Oh, okay. Yeah. Yes. Yes. No, it's fine. It's fine. Yeah. Integers are all the negatives and the positive numbers. So anything from negative infinity to positive infinity. Oh, you see. So integers will involve the negative and the positive. No problem. Then after, we've got the rational numbers. Rational numbers can be defined in 2 ways. Ne? Recurring numbers, like 2, 2, 2, 2, 2, 2, 2, something like that. Sometimes it's represented by this. If you see a dot on top of a number, then this symbol means this number is recurring. So any number that's recurring will be rational. And then also finite decimals. Finite decimals. So decimals that come to an end, like 0,456. Can you see you have 3 decimals? They're not going, it's not random numbers going up to infinity. And then irrational numbers. Irrational numbers are numbers that are non-recurring. And then infinite or infinite. Infinite, yeah. So infinite decimals. So they've got countless decimals. They go on. And an example that we always use is a pi. Pi, look at pi. Shift pi equals to, look at the numbers. The numbers are random, firstly. They're not recurring. It's not one number repeating itself. And they're going on. This is only the numbers that the calculator can show because of space, but it goes on. If you had a bigger calculator, you're going to see that the numbers are keeping on repeating itself randomly. There's no even a pattern. So 1,4515,14. What did I say? 45. Okay. There's no 45 here. It's 54 and it's going on. 3 comma something like that. Are we all fine? Okay, now we can answer the questions because now we have the knowledge and the knowledge. So the first one is -2. Okay, what are we doing? -2 1/3. Can you see it's recurring? So I got it as a decimal. And then if you don't get it as a decimal, you can just see one of the definitions of rational number said is any number that can be written as a over b, where b is not 0, where the denominator is not 0. So all are fractions. So let me just put it here. Number 3. Let's just edit here. All the fractions are rational numbers. I think it's cool. Isn't that cool? Yeah. If you see a fraction, you just say rational number. So the first one, it is a rational number. So I'm going to put it where? I'm going to put it under 2.2.1. So I'm going to say, what am I writing? Rational number. -2 1/3. That number is a rational number. Okay, 9 pi. Okay, you see, you get random numbers. There's no pattern. There's no blah, 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 blah. So 9 pi will be what? It will be irrational. So 9 pi is irrational. We're done with those two. Square root of 20, let's see. Square root of 20, let's get it as a decimal. It is also irrational. Can you see look at the decimals? They're infinite. The numbers are going on and they are random. There's no pattern. So this man is also what? An irrational number. Irrational like it doesn't make sense. How many people are irrational? How many people do you know that are irrational? I know 5. Okay, this one, 1,23. So this number there on top, can you see those dots that I told you about? What do they mean? They mean that the numbers are recurring. So in actual fact, this is 1,2323232323. You know, it's going on like that. So you see, it's recurring. We've got 23 repeating itself continuously. So what did we say it falls under? Recurring numbers are what? Are rational. Yes, correct. I had someone say it. It's correct. So this one is going to go under rational. So 1,23 like that. Are you all clear? Okay. -3, it falls under what? It falls under integers. So I'm going to write it under integers. Integers is 2,12. So here, integers. But we know that according to that rule, all rational numbers are integers, are whole numbers, and then they are what? They are rational numbers. So this also falls under rational numbers. I hope you get that part. And then square root of 16 is what? It's 4. We all know that, right? Square root of 16 is 4. So 4, it's according to our definition, 4 falls under natural numbers, under whole numbers. There will be 4 there also, because of natural numbers are all the positive numbers starting from 1. So 1, 2, 3, 4 is there. Whole numbers, all the positive numbers starting from 0. 0, 1, 2, 3, 4 is there. Negative numbers is integers is negatives and positives. So 4 is there also. Can you see? So I'm gonna have 4 there. I'm gonna have 4 there. I'm gonna have 4 there. It's a natural number, a whole number, an integer, and it's also rational. Yeah. I don't know how they're gonna mark this. 2 is gonna fall also, same thing. It's gonna fall under rational numbers, under integers, under whole numbers, under natural numbers. Done. So I don't know how they're gonna mark everything. Maybe they wanted one question, one answer for each, but at least we managed to solve it. It's a revision on the number system, and it's very useful in grade 10 and grade 11 and grade 12, especially when you're dealing with roots. So you need to know this. Know it. The sooner you know it, the better. Okay, so we're gonna work this part out. Let me see. How much time do we have left? This thing doesn't want to end. Okay, let's try to be quick. Hey. Okay, 3 numbers of the product numbers are given below. Use these prime numbers to determine the highest common factor and the lowest common multiple. Perfect. So remember, how do you find the highest common factor using prime numbers? You're gonna take the numbers that appear, the bases that appear in all these 3 numbers here, and you take the ones with the lowest exponent. So 2 appears in all of them. So let's start. Highest common factor, I have a 2. And then 3 appears in all of them. I have a 3. 7, do I have 7 in? Okay, I have a 7 and a 7 on this one. 924 and 642. But I don't have a 7 in 132 here. So I can't take it. It's not a common factor. But I have 11. I have 11, right? Take the bases that are common, and then you're going to take the ones with the lowest exponent. So what is the lowest exponent between the 2's? It's 1. This one is the lowest one. Here, they are all the same. So I'm just going to take that one. And 11 also, they're all the same. So that will be the highest common factor. Will be 6 times 11, which is 66. And the lowest common multiple is quite different. You list all the bases that you see, all of the bases. So if anything is a base I see, let me just look at the first one, and then I'm gonna check. So I'll list all the bases. I've got 2, 3, 7, 11. Is there any other base that I'm missing? Then I'm gonna check in the other prime factors if there's any other base. So let's say here there was maybe a 9. I was going to include a 9 there. Even if that's where it only appears at this, I have to write it there. I hope you get it. Then I'm going to take the highest exponents for all of this. So the highest exponent for 2 is a square. The highest is still 1. Yeah, for all of them it's still 1, the highest exponent. Then I'm going to work it out on a calculator. So 12 times 7 times 11, it's 924. That's the lowest common multiple, just like that. Sharp. Determine the number that makes the following statement true. 78 minus a certain number equals to 92. Okay, so I'm going to make this into, I'm going to formulate a fraction out of this. Subtract a certain number, it's minus 72. Take 72 that side, minus 72 equals to that 78. Can you all see? What did I do? I took 78 that side. When it goes that side, it changes sign. If it's a positive, it becomes a negative. I still have a negative sign. X, let it represent a certain number. We don't know what that number is, so I just wrote it as X. I hope you can see. So 92 minus 78 is how much? It's 14. And then X, and then I'm gonna divide both sides by a -1 so that I have a 14, -14, and it makes sense because of so that if you have a negative and a negative, it's gonna be a positive. So basically we're gonna add. So the answer is -14. If you subtract 78 minus negative 14 will give you 92. Hope you get it. And this one, they say solve this question without the use of a calculator. So how are you gonna do such a question? Blah blah blah. Can you see it? I feel like this part is so tiny. There's the question there. Can you see it? This is how the use of a calculator. So you're gonna apply BODMAS here. You're gonna apply BODMAS. This part and this part is gonna cancel out. Multiply this first part. Obviously, you can multiply this part alone and multiply that part alone. I hope that's what they're looking for. So 33 plus 195 times 27, 5298. This is gonna cancel out because it's the same thing. Yeah? 16 minus 195 times 196, and then 5298 divided by 796. Simplify this, 2649 over 398. Okay. I hope that's the answer. If they say without the use of a calculator, they're simply saying show your workings. Don't just press this whole thing on a calculator. Show the steps of how you got it. Obviously, in this case, we're gonna apply BODMAS, and then also at the bottom, and then see if there's a number that goes into both of them. You simplify it just like that. I hope it's correct. So I'm doing this paper with you. I haven't seen the paper before, so I'm allowed to make mistakes. All right? Yes, but I shouldn't make mistakes. But I can make mistakes, but I mustn't make mistakes. Okay, it's fine. So here, what do? We're gonna deal with integers. Can you see? We're dealing with integers. So what you need to know is that a negative multiplied by a negative will give you a positive, and a negative will give you a negative. A negative, a positive, and a positive will give you a positive. A negative and a positive will give you a negative. So you need to know the signs, and it's easy. When I teach this, I say you don't have to know and cram this. Look, when you're multiplying the similar signs, you're always gonna get a positive. If the signs are the same, look at plus and a plus, you get a positive, and you multiply different signs, you get a negative. You see? So if you get, okay, I don't know what example to use, but if they are the same, positive is a good thing. If they are different, it's a bad thing. You get a negative. Whatever, you'll figure it out yourself. So this one stays the same. A negative and a positive will become a positive. 12 there. 3 times this one is 12. And then negative, this one, it's 3 times. So it's a negative and a negative and a negative. So a negative and negative is a positive and a negative is a negative. So the final answer will be a negative 8. Do you see it? Then we work it out. Minus 5 plus 12 minus 8. It's 1. Okay, is it 1? Yes, it's 1. And then let me see. If I press the whole thing for minus. Yeah, so you can get a mark, but if it's 3 marks, look, it's 3 marks. So they're gonna give you a mark for getting the sign correct and a mark there. 2 cubed, show that it's 8, and then the final answer. So they might give you marks something like they might mark it like that. So you can't just go straight and press it on a calculator. You need to show all your workings. You need to show them how you got the 12 is positive because a negative and a positive, a negative and a negative is a positive. 3 times 4 is 12. And okay, what did we do here? No, this is wrong. This is wrong. Sorry. So this answer will give us a negative, but I have a negative there. So what happened? Okay, here I'm supposed to have a negative inside. So a plus, can you see? So it changes the whole thing. Yeah, sorry about that, people. So I have 12 plus 8 is 20 minus 5, so it's 15. The answer is a positive 15. Yeah, sorry about that. Here there's a negative answer and then there's a positive outside, so you're gonna have a plus. Yeah, just note that one. Apologies about that question. Let's move quickly and finish this thing. And then also here you need to show all your workings. You can't just press this. You can press it on the calculator, but look at the mark allocation, it's 5, so you can't just you know what, you can't just do what, you can't just write the final answer. I mean, we don't do that in maths. Maybe in other maths. Okay, 612 is 6 squared is 36, and then negative, I have a negative outside. The square root of 9 is 3. I have a square. Can you all see the square? Plus the cubic root of 27. Press it on a calculator, will give you 3. And over negative 2 squared will be a negative 4 times 1 to the exponent 5 will be 1 plus 1. So nothing changes there. And then we work out what is workable. 36 minus 3 squared will be 9. A positive and a negative will be a negative over minus 4 times 1, it remains minus 4 plus 1. Okay, so this times this, it's minus 12. So I've got 36 minus 12 on top over minus 3. 36 minus 12, 2, that's 4. Is it 14? Here we need a calculator. Okay, 24. Yeah, man, why am I saying 14? And then divided by 3. So a positive and a negative will give us a negative. 3 goes into 24 8 times. So something like that. I hope you're getting it, you're following. You are massively following. This thing is disturbing the view, but I hope you can see it. Let's look at this question. Can I write it here so that you can see it better? So it's something like this, over 9x squared. Okay, y squared minus 1 times 3 minus 3. 4 marks. Okay, so what are we gonna do here? Yeah. We're gonna first deal with the bracket. Bracket means multiply, so multiply everything first. So 3 squared, this and this is 4, this and this is 1, it's 2, sorry. So remember, if there's nothing, there's an invincible 1, so 2 times 1 is 2, 2 times 2 is 4, over 9. I can change it. Do you all agree? I can make it into what? Into a prime base. 9 is made by 3 squared. So I can have 3 squared there, and then multiply it by minus 1. So it's gonna be minus 2. I hope I'm not losing anyone. Are you with me there? How can I put it? And then 3 times this one, it will be x. A negative and a negative will be a positive, so I have 3, and then a negative and a positive will be a negative, and then I still have that one there. So then I'm going to apply the laws of exponent. The laws of exponent says if you are multiplying parts of the same base, you add the exponents, and if you are dividing parts of the same base, you subtract. So I'm going to combine those two laws in one, if you allow me. So law 1 says if I have this, I'm gonna add, right? And law 2 says if I have something over something and the bases are the same, I'm gonna have to subtract. Are we all clear? So let's work it out here. 3, I'm gonna, powers of the same base, I'm multiplying, so I'm gonna add this 2. So I'm gonna have 2 plus minus 3. So 2 plus minus 3 will be minus 3. Do you all understand? Then when dividing parts of the same base, we're going to divide. So please, I shouldn't lose anyone here. When I divide, I subtract. So I'm going to have a negative, open a bracket, and negative. So a negative and a negative will give me a positive. So I'm going to have a plus 2 there. When this one goes on top, it changes the sign, basically. Then I go to the x. When dividing powers of the same base, I do what? I subtract. So that's what I'm saying. When it goes on top, it changes sign. If it's a positive, when it goes there, it's going to be a negative. So I'm dividing part of the same base. I'm going to subtract the exponents. And this one, you can guess what is it going to be. It's going to be plus 2. Can you see? So let's work it out. The answer here is minus 3. The answer there is 2. 4 minus 1 is 1. And then that one is 4. So therefore, let me write it here. The answer will be x, y, 4 over 3. If you have to write this as a positive exponent, that will be the answer. If not, you end here. That will be your answer there. Perfect. Perfect. Let's go to number patterns. Number patterns, you have to count the shapes. So the first one is 1, 1, 2, 3, 4, 4, 2, 3, 4, 5, 6, 7, 8, 9, 9. Which one is this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here, am I right? Let me see. 1, 2, 3. 13. So it's 13. Okay, it's 13. Write down the number of squares per shape in the form of a sequence. Hey, what are they saying? What are they saying? So this one, if I write it as a square, it will be 1 squared. This one, if I write it as a square, it will be 2 squared. I think this one, if I write it as a square, will be 3 squared. So this one, write down the number of squares per shape, or the number of squares in each shape. So it's 1, it's 4, it's 9, the number of squares. So we're just supposed to count. Per shape is 13. Use the above diagram to use your answer in question 1. Determine the number of squares in the 7th shape. So let's try to look at a pattern here. 1, 4, 9, 13. From there to there, they added 3. From there to there, they added what? 5. From there to there, they added what? 9 minus 13. I don't understand what's happening. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I don't know if they didn't do. Oh man, low shading. Oh man, I'm gonna have to continue in the dark. Can you see? So if they didn't do a mistake, maybe there's something I'm missing. But according to me, when I look at this one is 1 squared. It's made by 1 squared. This one is 2 squared. You get 4. This one is 3 squared. You get 5. So my guess will be this one was supposed to be what? 4 squared to be, so that it's 16, I think. But it's like I'm missing something. Then from here to here, from 1 to 3, they added how much? They added 3. From 4 to 5, they added 5. Right? So from 9 to there, they added 4. So how much will be this one? If they made a mistake, the answer will be 49. If they didn't make a mistake, I don't know. Okay, you'll tell me maybe if I missed something. Please comment and tell me, so that we save the country. So according to me, this will be n squared. You're just squaring the number of terms. The term number will give you the actual number there. Okay, use the above to determine the position of the shape that has 201 shapes. 201. Okay. Let me see. But the pattern should be the same. 1. Hey, I made a mistake, you see. 1, 2, 3, 4, 5. Yeah, I made a mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually it's okay. I won't stop the video. Yeah? Let me just fix it here. Because of we went too far. I can't stop it now. It's 5. It's 9. It's 13. So let's look. From here to here it's 4. From here to here it's 4. Oh, perfect. So my mistake was with this one. Yeah? So let's answer the question here now. Write down the number of squares we wrote it. 3.3.1. So 3.3.2. The 7th shape will have what? So this is the first one, shape 1, term 2, term 3, term 4, term 5, term 6, term 7. So I'm just going to add 4 here. I'm going to have 17. Add 4 here, you're going to have what? 21. Add 4 here, you're going to have 25, I think. So 13 plus 4 plus 4 plus 4. Sharp. So term 7 will be 25. Okay. And then find the general rule. The general rule, we use this one. It differs according to how you are taught, but this is the formula that we use. This, we're going to write the first term, and here we're going to write the constant difference. So the first term of this sequence is 1, n minus 1 times the difference is what? It's 4. Are we still together? Yes, it's 4. And you're going to multiply in here. 1 plus 4 times n is 4n. 4 times minus 1 is minus 4. 4, then you add the like terms. 1 minus 4 becomes minus 3. So that will be the general term that you can use to calculate any term number in any position. Yeah? And they say above, determine the position of the shape that will have 201 shapes. So which shape will have 201 shapes? We want to know. So what are we going to do? We're looking for the shape number. Yeah, the number, which position will be that one. So we're looking for n. So I'm going to substitute this here and then solve for n like we would normally solve for x. So take this one there, it's going to be a positive, and then 0, and then it's going to be what? It's going to be 4. Divide both sides by 4. So 204 divided by 4 is 51. So shape number 51, or the 51 term, will have 201 squares. The shape, the way they drew it, yeah, whatever they drew it, yeah, it will have 51. It will have 201, shape number 51. Okay, because of the load shading, I think we should just end it there. But the rest is fairly easy. This is relationships. You just substitute input and output, and then you square there. Thank you so much. Sorry for the mistake that I did here. I didn't count this correctly at the beginning. That's why I struggled here. I was supposed to count it nicely. So here I have 1, 2, 3, 4. I have 5 squares here, not 4. So that's why the whole thing became messed up. So, but at least we managed to get it sharp. Thank you.